Number 4. A child with mass m rides on an irregularly curved slide of height 2 meter. As shown in figure, the child start from rest. Start from rest at the top. A. Determine the speed at the bottom. Speed of the bottom V, assuming no friction is present. And then B, if the force of kinetic friction act on the child, B ada friction, how much mechanical energy does the system lose? Assume that V final 3 meter per second and mass 20 kg. Assumption ni adalah untuk soalan B. Assumption yang V final adalah 3 meter per second dan mass 20 kg ni adalah untuk soalan B. Sebab soalan A kita kena cari final speed dia, V final dia. And kita buat assumption no friction. A, assumption yang dibuat adalah no friction. No friction. And then kita kena cari V final. Final speed at the bottom. So untuk yang ni kita boleh apply conservation of energy. Total energy initial equals total energy final. So first we have to identify what kind of energy at initial position. And then what kind of energy at final position. Initially the child is at particular height. So the child have potential energy. And then the child at rest, so it has no kinetic energy initially. And then at final position, the child is at ground level, so it has no potential energy, but it's still moving. Still moving, and we want to find the speed of the motion at final position. There's kinetic energy, final position. And then you have to write formula of potential energy mg hi. Kinetic energy initial is 0, so kita boleh cancel dah kat awal ni. And then dekat final potential energy dia 0, boleh cancel dah. K final dia, kinetic energy final, formula dia adalah half mv squared. So both equation have m, so we can cancel m. So we don't need value of m for equation A. Then we can substitute G, Hi, height initial is 2 meter. And then V is the unknown that you have to find. So V equals 9.81 times 2 square root answer. So the value is 6.26 meter per second. Question B. If the force of kinetic friction act on the child, how much mechanical energy does the system lose? Assume that final velocity is 3 meter per second and mass 20 kg. Untuk soalan B, kita kena apply conservation of energy with dissipative forces. Total energy, yang ni B, total energy initial, plus energy loss, plus energy loss equals total energy final. Okay, total energy initial plus energy loss equals total energy final. So energy loss adalah disebabkan oleh friction. Okay, due to friction. Okay, so untuk soalan B ni dia nak cari how much mechanical energy does the system loss. So nak cari energy loss berapa lah. Okay, nak cari energy loss berapa. So maybe kita boleh let energy loss as a subject. Siap? Okay, so energy loss equals to total energy final minus total energy initial. So untuk energy final, okay, kat final position ni dia ada kinetic energy final. Okay, kinetic energy final, and then potential energy final kosong. Okay, sebab dia dekat ground level. And then dekat initial yang ni okay, kinetic energy initial tak ada sebab dia at rise. Okay, tapi dia ada potential energy initial sebab dia dekat particular height from ground level. Okay, so kita boleh cancel siap-siap U final. Tak ada, kosong tadi. And then initial tak ada kinetic energy. Okay, kita dah boleh potong siap-siap. Okay, and then kita boleh tulis formula lah. Kinetic energy final adalah half mv final. Okay, so saya letak simbol final velocity adalah V. Kat sini dia letak final velocity simbol adalah VF. Okay, so V yang saya maksudkan kat sini adalah final velocity lah. Okay, V squared. And then minus dengan potential energy initial, formula dia adalah mg height initial. Okay, so kita boleh substitute dah lah. Mass dia adalah 20 kg. Final velocity adalah 3 meter per second. Okay, minus mass 20 G 9.81. And then height initial 2 meter. Okay, so careful yang ini. Make sure kamu dapatkan dulu answer untuk half times 20 times 3 squared. Dapat answer dulu. Then baru minus in bracket 20 times 9.81 times 2. Okay, so dapat negative 202 202.4 joule. So energy loss adalah negative 302.4 joule. Okay, so negative ni because work is done on the system. Okay, sorry, work is done by the system. System ni maksudnya the chart lah. Okay, work is done by the system to overcome the friction. Okay, dia nak overcome friction, dia kena buat kerja sebanyak 302.4 joule. Okay, untuk mengatasi friction. Okay, kalau negatif maksudnya work is done by the system. Okay, positif maksudnya work is done on the system. Okay, ada orang lain yang buat kerja ke atas sistem, yang bagi external force ke. Okay,